I am a bottlenose dolphin, Tursiops truncatus, one of the most studied and recognized members of the family Delphinidae, the oceanic dolphins. My family belongs to the order Cetacea, which includes all whales, dolphins, and porpoises. And within that order, I am part of the suborder Odontoceti, the toothed whales. This places me in a lineage that diverged from the baleen whales, the Mysticeti, tens of millions of years ago. My ancestors were terrestrial mammals that returned to the ocean roughly 50 million years ago, undergoing one of the most dramatic evolutionary transformations known to science. Over millennia, limbs became flippers, bodies became streamlined, nostrils migrated to the top of the head to form a blowhole, and an entirely aquatic existence was achieved. I share common ancestry with hippopotamuses and even-toed ungulates, a fact that surprises many who assume my closest relatives must be fish. I am a mammal, warm-blooded, breathing air, giving live birth and nursing my young with milk. Within the genus Tursiops, there is ongoing debate about how many species exist. Some researchers recognize only one species, Tursiops truncatus, with multiple ecotypes or regional forms. Others recognize at least two species, Tursiops truncatus, the common bottlenose dolphin, and Tursiops aduncus, the Indo-Pacific bottlenose dolphin, which is generally smaller with more spots and a longer beak. There may be additional species or subspecies, and genetic studies continue to refine our understanding. Throughout this narrative, when I refer to myself as a bottlenose dolphin, I am speaking primarily of Tursiops truncatus, though much of what I describe applies broadly to the genus and to many other dolphin species. I am not to be confused with porpoises, which belong to a different family, Phaconidae, and differ in body shape, tooth structure, and behavior. Porpoises are generally smaller, have spade-shaped teeth rather than conical teeth, and lack the pronounced beak that I possess. I am immediately recognizable by my robust, streamlined body and my short, stout beak. My body is fusiform, torpedo-shaped, designed for efficient movement through water. Adult bottlenose dolphins typically measure between 2 and 4 meters in length, with considerable variation depending on population and sex. Coastal populations tend to be smaller, with adults averaging 2 to 2.5 meters, while offshore populations can reach 3 to 4 meters. Males are generally larger than females, a pattern called sexual dimorphism, though the difference is not extreme. An adult male may weigh between 200 and 300 kilograms, while a female typically weighs between 150 and 250 kilograms. The largest individuals can exceed 600 kilograms. I grow throughout my life, though growth slows significantly after reaching sexual maturity. My skin is smooth and rubbery, without scales or hair except for a few vibrissae, whisker-like sensory hairs, present around the rostrum at birth but lost within days or weeks. My coloration is countershaded, dark gray to charcoal on the dorsal surface, fading to lighter gray on the sides, and pale gray to white or pink on the belly. This countershading provides camouflage. When viewed from above, my dark back blends with the deep water below. When viewed from below, my pale belly blends with the bright surface lit by sunlight. The exact shade varies among individuals and populations, with some dolphins appearing nearly black and others a lighter bluish gray. My skin is not static. It regenerates rapidly, sloughing off the outer layer every few hours. This constant renewal keeps my skin smooth and free of algae and barnacles, maintaining hydrodynamic efficiency. Some bacteria and other microorganisms do colonize my skin, and I may carry scars from encounters with sharks, other dolphins, or human activities such as boat strikes or entanglement in fishing gear. My dorsal fin rises from the midpoint of my back, tall and curved, though the shape and size vary among individuals. The dorsal fin is used for stability, helping me maintain balance during tight turns and rapid swimming. It is composed of dense connective tissue, not bone, and it is supported by blood vessels that help regulate my body temperature. In warm water, blood flow to the fin increases, dissipating heat. In cold water, blood flow decreases, conserving warmth. My pectoral flippers, located on either side of my body just behind my head, are modified forelimbs. Beneath the skin and blubber, I retain the bone structure of a mammalian arm. Humerus, radius, ulna, carpals, metacarpals, and phalanges, all compressed and enclosed in a hydrodynamic flipper. I use these flippers for steering, slowing, and sometimes for social touch, stroking other dolphins or guiding a calf. My tail, or caudal fin, is horizontal, unlike the vertical tails of fish, and it is powered by strong muscles in my tail stalk. I propel myself by moving my tail up and down, not side to side, a motion that reflects my mammalian ancestry. The tail flukes are composed of tough connective tissue, and they provide the thrust that drives me through the water at speeds that can exceed 30 kilometers per hour in bursts, with cruising speeds typically between 5 and 15 kilometers per hour. My head is rounded, with a distinct melon, a fatty structure in my forehead that plays a critical role in echolocation. The melon focuses and directs the sound waves I produce, shaping them into a beam that I project forward into the water. My beak, or rostrum, is short and bottle-shaped, giving me my common name. Inside my mouth, I have between 18 and 26 pairs of conical teeth in both my upper and lower jaws, totaling roughly 80 to 100 teeth, though the number varies individually. These teeth are not used for chewing. I swallow my prey whole or in large pieces. My teeth are for grasping slippery fish and squid, holding them securely until I can position them for swallowing. As I age, my teeth wear down, and in very old individuals, they may be reduced to blunt pegs or even lost entirely. Tooth wear can be used to estimate age, with layers of dentine and cementum deposited annually, similar to growth rings in a tree. Researchers extract teeth from dead dolphins and section them under a microscope to count these layers, providing an age estimate. My blowhole sits atop my head, a single opening that is the external nostril. Unlike terrestrial mammals, which have two nostrils, I have a single blowhole formed by the fusion of the nasal passages. Beneath the blowhole is a complex system of air sacs and nasal passages that I use to produce sound. When I breathe, I rise to the surface. The blowhole breaks the waterline, and I exhale forcefully, expelling a spout of moist, warm air that may be visible as a low, bushy spray. I inhale rapidly, filling my lungs in a fraction of a second, and then I close the blowhole and submerge. The blowhole is sealed by a muscular flap, and I can hold my breath for several minutes, typically 3 to 7 minutes during routine dives, though I am capable of longer dives if necessary. My lungs are proportionally smaller than those of terrestrial mammals, but I exchange air more efficiently, replacing up to 90% of my lung volume with each breath, compared to 15 to 20% in humans. This efficient gas exchange allows me to maximize oxygen uptake and minimize the time I spend at the surface, where I am more vulnerable. I see well both underwater and in air, though my eyes are adapted primarily for the aquatic environment. My eyes are positioned on the sides of my head, giving me a wide field of view, nearly 360 degrees, with a small blind spot directly in front of my rostrum and directly behind my tail. I have binocular vision forward and downward, allowing me to judge distances when pursuing prey. My retina contains both rods and cones, meaning I have some color vision, though it is not as developed as in primates. I can distinguish blues and greens, but my perception of reds and longer wavelengths is limited or absent. Underwater, light is filtered by depth, and red wavelengths are absorbed quickly, so color vision is less useful than sensitivity to contrast and movement. My eyes are protected by a thick cornea and by a nictitating membrane, a third eyelid that can sweep across the eye to remove debris. I produce large volumes of oily tears that coat the eye and protect it from the salt water. My lens is nearly spherical, an adaptation for focusing underwater, where the refractive index of the cornea is nearly the same as that of water, rendering it ineffective for focusing. On land, my vision is somewhat impaired by this lens shape, but I can still see reasonably well when I leap above the surface or spy hop, raising my head vertically out of the water to look around. Hearing is my most important sense. I perceive sound across a vast range of frequencies, from roughly 100 Hz to 150 kHz, far exceeding the human range of 20 Hz to 20 kHz. My ears are tiny openings on either side of my head, just behind my eyes, and they lack external pinning. Sound reaches my inner ear not primarily through these openings, but through my lower jaw and specialized fatty tissues that conduct sound to the auditory bones. This allows me to hear directionally, determining the source of a sound with remarkable precision. My auditory system is adapted to the underwater environment, where sound travels faster and farther than in air, roughly 4 times faster, at about 1,500 meters per second. I use sound constantly, to navigate, to find food, to communicate, and to maintain social bonds. Echolocation is my primary means of perceiving the world in detail. I produce clicks, sharp, broadband pulses of sound, by forcing air through the nasal passages beneath my blowhole. These clicks are focused by the melon into a directional beam and projected forward. When the sound waves encounter an object, they bounce back as echoes. I receive these echoes through my lower jaw, and my brain processes the time delay, intensity, and frequency content to construct a detailed acoustic image of the object. I can determine its size, shape, distance, speed, and internal structure. I can distinguish between a fish and a rock, between a solid object and a hollow one, between species of fish based on their swim bladder shape. Echolocation is so precise that I can detect a fish buried in sand or a wire thinner than a human hair. I use it to hunt in murky water in darkness and at depths where light does not penetrate. I produce clicks in rapid sequences, sometimes hundreds per second, adjusting the rate and intensity based on the task. When searching for prey at a distance, my clicks are spaced farther apart, allowing time for echoes to return from distant targets. As I close in, I increase the click rate, producing a terminal buzz, a rapid series of clicks that provides continuous real-time information as I home in on the prey. My sense of touch is acute. My skin, especially around the blowhole, the flippers, and the genital area, is rich in nerve endings. I engage in frequent physical contact with other dolphins, rubbing, stroking, and caressing, behaviors that reinforce social bonds and reduce tension. Mothers and calves are in near constant contact, and adult dolphins often swim in close formation, their bodies touching. I also use my rostrum to probe the sea floor, pushing into sand and mud to uncover buried prey, and I can feel the texture and resistance of different substrates. My vibrancy, present at birth, may provide additional tactile information, though they are lost early in life, and their function is not fully understood. Some researchers suggest they help newborns locate the mother's mammary slits for nursing. I taste and smell poorly, if at all. My tongue has few taste buds, and I lack olfactory bulbs in my brain, the structures responsible for processing smell. In the underwater environment, chemical communication is less important than it is on land, and my reliance on sound and vision has eclipsed the need for taste and smell. There is evidence that some dolphins can detect certain chemicals in the water, but this is not well understood and may involve structures other than the classic olfactory system. I live in coastal and offshore waters, in temperate and tropical oceans around the world. Bottlenose dolphins are found in the Atlantic, Pacific, and Indian Oceans, in bays, estuaries, harbors, and the open sea. My range extends from approximately 45 degrees north latitude to 45 degrees south, though I am most abundant in warm and temperate waters. Coastal populations, often called inshore ecotypes, inhabit shallow waters less than 30 meters deep, frequenting bays, river mouths, and coastal lagoons. Offshore populations, or pelagic ecotypes, range far from land, over the continental shelf and beyond, in waters hundreds or thousands of meters deep. These ecotypes differ not only in habitat use, but also in morphology, genetics, and behavior. Coastal dolphins tend to be smaller, lighter in color, and have larger flippers relative to body size. Offshore dolphins are larger, darker, and more robust. There is limited mixing between ecotypes, and they may represent distinct populations or even subspecies. I am highly adaptable, occupying a wide range of marine environments. I tolerate varying salinities, from full seawater to brackish estuaries, and I have been observed in river mouths and even in freshwater rivers for short periods, though I do not typically reside in freshwater. I am a warm-blooded endotherm, maintaining a core body temperature of approximately 36 to 37 degrees Celsius regardless of the surrounding water temperature. My thick layer of blubber, a subcutaneous fat layer that can be several centimeters thick, provides insulation, energy storage, and buoyancy. Blubber thickness varies seasonally and with body condition, increasing when food is abundant and decreasing during periods of scarcity or high energy demand, such as pregnancy and lactation. In cold water, I reduce blood flow to the skin and extremities, shunting blood to the core to conserve heat. In warm water, I increase blood flow to the skin, flippers, and dorsal fin, allowing excess heat to dissipate. I also behaviorally thermoregulate, seeking warmer or cooler water, swimming faster to generate heat, or resting to conserve energy. My day is structured around feeding, socializing, traveling, and resting. I do not sleep in the way terrestrial mammals do. I cannot afford to lose consciousness entirely, as I must surface regularly to breathe. Instead, I engage in unihemispheric slow-wave sleep, a state in which one half of my brain sleeps while the other remains awake. During this time, one eye is closed and the opposite hemisphere of my brain shows slow-wave activity, while the other eye remains open and the corresponding hemisphere maintains vigilance. I alternate which side sleeps, and I continue to swim slowly, surface to breathe, and respond to threats. This allows me to rest while remaining functional. Resting typically occurs at night or during midday, and it may involve logging, floating motionlessly at the surface, or swimming slowly in tight circles. Feeding occupies much of my time and energy. I'm a carnivore, preying primarily on fish and squid, though my diet varies by location, season, and availability. Coastal dolphins often eat bottom-dwelling fish such as mullet, croakers, and catfish, as well as shrimp and crabs. Offshore dolphins consume schooling fish like mackerel, herring, and flying fish, as well as squid and occasionally jellyfish, though jellyfish are low in nutritional value and likely consumed opportunistically. I am a generalist and an opportunist, adjusting my diet to exploit whatever prey is abundant. In some regions, I specialize on particular prey or employ unique foraging strategies that are passed down through generations, examples of cultural transmission. I hunt using a variety of techniques. I may chase individual fish, using my speed and agility to outmaneuver them. I use echolocation to track the fish, adjusting my trajectory to intercept it. I may herd schools of fish, working alone or cooperatively with other dolphins. In a behavior called fish whacking or tail slapping, I strike a fish with my tail flukes, stunning or injuring it, making it easier to capture. In some populations, I engage in strand feeding, a remarkable and risky behavior in which I chase fish onto mudflats or beaches, partially beaching myself to seize the fish, then wriggling back into the water. This behavior is learned, and only certain populations practice it, particularly along the coasts of South Carolina and Georgia in the United States. Mothers teach their calves this technique, and it requires precise timing and knowledge of tides and geography. In other regions, I use sponges as tools. I tear a marine sponge from the sea floor and wear it over my rostrum, protecting my sensitive skin as I forage in rough, rocky substrates where prey hides. This behavior, called sponging, is also culturally transmitted, passed from mothers to offspring, and it is more common in females than in males. Sponging dolphins tend to be more solitary and spend more time foraging, suggesting that the technique, while effective in certain habitats, may require more time or effort than other methods. Tool use in dolphins is rare but well documented and represents one of the few examples of habitual tool use in a marine mammal. I may also cooperate with other species. In some areas, dolphins and fishermen work together. The dolphins herd fish toward the fishermen's nets, and in turn, the fishermen share a portion of the catch, or the dolphins capitalize on fish that escape the nets or are discarded. This mutualistic relationship has been documented in Brazil, Myanmar, and other regions, though it is not widespread and appears to be learned and maintained through cultural transmission rather than instinct. In other cases, I associate with seabirds, which dive and point to fish schools, or with larger predators such as sharks or whales, scavenging or capitalizing on prey they disturb. Digestion begins in my multi-chambered stomach, which is divided into 3 sections: the forastomach, which may serve a storage function, the main stomach, where enzymatic digestion occurs, and the pyloric stomach, which further processes food before it enters the small intestine. I do not chew my food, so digestion relies on strong stomach acids and enzymes to break down flesh and bones. My intestines are long, and absorption of nutrients is efficient. I excrete waste continuously as I swim, and I urinate frequently, diluting the high salt intake from my marine diet. My kidneys are highly specialized, capable of concentrating urine and excreting excess salt, maintaining osmotic balance in a hypersaline environment. I face predation primarily as a calf. Adult dolphins have few natural predators, but large sharks, particularly great white sharks, bull sharks, and tiger sharks, will attack and kill dolphins, especially young, injured, or solitary individuals. Orcas or killer whales, Orcinus orca, also prey on dolphins, though this varies by orca population. Some orca ecotypes specialize on marine mammals, including dolphins, while others eat fish and do not hunt mammals. In regions where mammal-eating orcas are present, dolphins are wary and may flee or mob them, emitting alarm calls and swimming in tight groups for protection. Calves are most vulnerable to predation. They are smaller, slower, and less experienced than adults, and they may become separated from their mothers during chases or in turbulent water. In addition to predation, I face threats from disease, parasites, and environmental hazards. I carry a variety of internal parasites, including nematode worms, trematodes, and cestodes, which infest my lungs, stomach, intestines, and other organs. External parasites such as barnacles and copepods may attach to my skin, though my rapid skin regeneration and active swimming limit their colonization. I am susceptible to bacterial, viral, and fungal infections. Morbilliviruses, similar to the viruses that cause measles in humans and distemper in dogs, have caused mass die-offs in dolphin populations, killing hundreds or thousands of individuals in single outbreaks. Brucellosis, toxoplasmosis, and other diseases also affect dolphins, and immunosuppression due to pollution or stress can increase susceptibility. Human activities pose the greatest threats. Entanglement in fishing gear, including gillnets, trawls, and longlines, kills thousands of dolphins each year worldwide. I become entangled while pursuing prey or while swimming through fishing areas, and I may drown if I cannot surface to breathe. Bycatch, the unintentional capture of non-target species, is a major conservation concern. Boat strikes injure and kill dolphins, particularly in busy harbors and coastal areas. Propellers can cause deep lacerations, and collisions can fracture bones or cause internal injuries. Noise pollution from shipping, sonar, seismic surveys, and construction disrupts my communication and echolocation, causing stress, displacement, and in extreme cases, physical harm. Loud sonar, particularly military mid-frequency active sonar, has been linked to mass strandings and hearing damage in some cetacean species, and dolphins are also at risk. Pollution degrades my habitat and my health. Chemical pollutants such as heavy metals, pesticides, and industrial compounds accumulate in my tissues, particularly in my blubber, which stores fat-soluble toxins. These pollutants can suppress my immune system, disrupt my endocrine system, and impair reproduction. Persistent organic pollutants, such as PCBs and DDT, although banned in many countries, remain in the environment and continue to accumulate in marine food webs. Plastics are ubiquitous in the ocean, and I may ingest plastic debris, mistaking it for prey, or become entangled in it. Microplastics, tiny particles resulting from the breakdown of larger items, have been found in dolphin tissues, though the health effects are not yet fully understood. Habitat degradation, including coastal development, dredging, and destruction of seagrass beds and estuaries, reduces the availability of suitable habitat and prey. Climate change is altering ocean temperatures, currents, and prey distribution, and I must adapt or shift my range in response. Warming waters may benefit me in some regions, expanding my range poleward, but in other areas, it may reduce prey availability or increase disease prevalence. Ocean acidification, the result of increased carbon dioxide absorption, affects the base of the food web, potentially reducing prey abundance. Extreme weather events such as hurricanes and cold snaps can cause strandings and mortality, particularly in shallow coastal areas where I may be trapped or exposed. I live in complex social groups called pods, though group size, composition, and stability vary widely. Coastal populations often form small, relatively stable groups of fewer than 20 individuals, with strong bonds among members. Offshore populations may form larger, more fluid groups of dozens or even hundreds of individuals, and the composition of these groups changes frequently. I recognize other individuals and maintain relationships over years or even decades. My social system is described as fission fusion, meaning that group size and membership change fluidly depending on activity, resource availability, and social factors. I may swim alone, with a close companion, or in a large aggregation, and I move between groups regularly. Within pods, social bonds are strongest among related females and their offspring, and among males that form alliances. Adult males often form long-term coalitions of 2 or 3 individuals, sometimes more, that cooperate to gain access to reproductive females. These alliances may last for years or even lifetimes, and they are critical for male reproductive success. Males in alliances coordinate their behavior, herding females, defending against rival males, and supporting each other in conflicts. Female dolphins tend to have broader social networks, associating with multiple individuals and groups, though they too form strong bonds with particular companions. Mothers and calves are nearly inseparable for the first few years of life, and even after weaning, they may maintain close relationships. Dominance hierarchies exist, but they are subtle and context-dependent. Larger, older individuals tend to be more dominant, and males are generally more aggressive than females, though females are not passive and can be assertive, particularly in defense of calves. Aggression is expressed through posturing, jaw claps, tail slaps, and physical contact such as biting and ramming. Serious injuries can occur, especially among males competing for mates, and scars from teeth rakes are common on the bodies of adult males. However, much social interaction is affiliative rather than aggressive. I engage in play, particularly as a juvenile, chasing, leaping, and manipulating objects such as seaweed or fish. Play serves to develop motor skills, practice social interactions, and establish bonds. Even adults play, suggesting that it serves functions beyond development, perhaps reducing tension or maintaining social cohesion. I communicate using a rich repertoire of sounds, categorized broadly into clicks, whistles, and burst pulse sounds. Clicks are used for echolocation and have been described. Whistles are tonal, narrowband sounds, frequency modulated and often melodic, ranging from about 2 to 20 kilohertz. Each dolphin develops a unique signature whistle, a stereotype sound pattern that functions as a name, identifying the caller to others. Calves develop their signature whistles in the first few months of life, and they retain them throughout life. I use my signature whistle to announce my presence, to maintain contact with group members, and to reunite with separated companions. Other dolphins can recognize individuals by their signature whistles, and they may mimic the whistles of others to address them specifically, a behavior analogous to calling someone by name. This capacity for vocal learning and referential communication is rare among non-human animals and highlights the cognitive sophistication of dolphins. Burst pulse sounds include squawks, barks, yelps, and other rapid, pulsed vocalizations used in social contexts, often during aggression, play, or excitement. The function of many burst pulse sounds is not fully understood, but they likely convey emotional state and behavioral intent. I also produce non-vocal sounds, such as jaw claps, slapping the water with my tail or flippers, and leaping and splashing. These percussive signals can convey information over long distances and in noisy environments where acoustic communication may be masked. Body posture and movement are also communicative. An arched back and open mouth signal aggression. Rapid swimming toward another dolphin can be a threat or an invitation to play, depending on context. Synchronous swimming, in which two or more dolphins move in tight coordination, surfacing and diving in unison, is a behavior that may strengthen social bonds and signal cooperation. Gentle touching, pectoral fin contact, and rubbing are affiliative behaviors that occur frequently among bonded individuals. I reach sexual maturity relatively late, a characteristic of long-lived, slower-producing species. Females typically mature between 5 and 13 years of age, with an average around 8 to 10 years, though this varies by population and individual condition. Males mature slightly later, between 9 and 13 years, though they may not successfully compete for mates until they are older and larger. Physical maturity, the attainment of full adult size, is not reached until the late teens or early 20s, and growth continues slowly even after sexual maturity. Breeding is seasonal in some populations, with peaks in births during warmer months, while in other populations, breeding occurs year-round. Females are polyestrous, cycling multiple times per year if they do not conceive, and they have an estrous cycle of roughly 21 to 42 days, though this varies. Males detect receptive females through behavioral cues and possibly through chemical signals, though the mechanisms are not fully understood. Courtship involves chasing, caressing, and vocalizing, and multiple males may compete for access to a single female. Males use aggression, displays, and coalition support to exclude rivals, and copulation is brief, lasting only seconds, though it may occur repeatedly. Mating is often vigorous and may involve multiple partners. Gestation lasts approximately 12 months, one of the longest gestations relative to body size among mammals. During pregnancy, the female's energy demands increase, and she must consume more prey to support fetal growth. Pregnant females often show changes in behavior, becoming less social or more selective in their associations. Birth typically occurs tail first, though head first births have been documented. The mother gives birth to a single calf. Twins are extremely rare and usually do not survive. The newborn is roughly 1 meter in length and weighs between 10 and 20 kilograms, roughly 1/3 the length of the mother and 1/10 her weight. The calf is born with its eyes open, and it can swim immediately, though its movements are uncoordinated. The mother or other dolphins may assist the calf to the surface for its first breath, nudging it upward. The bond between mother and calf is intense and enduring. The calf nurses frequently, every 20 minutes to every few hours in the early weeks, suckling from one of 2 mammary slits on either side of the mother's genital opening. The mother's milk is extremely rich, containing approximately 10 to 20% fat, much higher than human milk, which is about 3 to 5% fat and comparable to the milk of some seal species. This high fat content supports rapid growth. The calf grows quickly, doubling its length in the first year and continuing to grow for several years. Nursing continues for 18 months to 2 years or more, though the calf begins to take solid food at around 6 months to 1 year, learning to catch fish by watching and imitating the mother. The mother is the primary caregiver, though other members of the pod, particularly other females, may assist, a behavior called alloparenting or babysitting. These helpers are often relatives or close associates, and their assistance may allow the mother to forage more effectively or may provide learning opportunities for the helpers, who benefit by gaining experience before having their own calves. Calves are vulnerable, and mortality in the first year is high, estimated at around 20 to 30% in some populations, though this varies. Causes of calf mortality include predation, disease, starvation, and separation from the mother. Learning is a prolonged process. Calves acquire foraging skills, social behaviors, communication, and navigation through observation, imitation, and play. They are highly playful, practicing hunting by chasing and manipulating fish, seaweed, and other objects, and engaging in social play with peers and adults. This extended juvenile period, lasting several years, is characteristic of species with large brains and complex social systems. It allows for the development of cognitive and social skills necessary for success in a complex environment. Females typically give birth every 3 to 6 years, though the interval can be shorter or longer depending on calf survival and environmental conditions. If a calf dies, the mother may conceive again within months. If the calf survives, she invests heavily for several years, and her interbirth interval is extended. Over a reproductive lifespan of roughly 30 to 40 years, from first birth at around 10 years to cessation in the late 40s or early 50s, a female may produce 6 to 10 calves, though not all will survive to adulthood. Reproductive success is highly variable among individuals and is influenced by social status, body condition, habitat quality, and experience. Menopause, or reproductive senescence, has been documented in some female bottlenose dolphins, though it is not universal. Post-reproductive females may live for many years, and they may play important roles in the social group, such as assisting with calf rearing, sharing knowledge of foraging areas and techniques, and maintaining social cohesion. This post-reproductive life stage is rare among mammals, documented primarily in humans and a few species of toothed whales, including orcas and pilot whales, and possibly in bottlenose dolphins. The evolutionary significance is debated, with hypotheses focusing on the benefits of grandmothering, where older females increase the survival of their grand-offspring by assisting their daughters, or on social roles that benefit the group as a whole. Lifespan varies widely. In the wild, bottlenose dolphins can live 40 to 50 years, with some individuals documented to live into their 60s. Females tend to live longer than males, possibly due to the risks males face during competition and the energetic costs of maintaining larger body size and aggressive behavior. In managed care, lifespan is comparable or slightly longer, with access to veterinary care, abundant food, and protection from predators and environmental hazards. However, the stress of captivity, limited space, and social disruptions can negatively affect health and longevity, and there is ongoing debate about the welfare of dolphins in captivity. As I age, I accumulate scars, my teeth wear down, and my body condition may decline. Older individuals may be less able to compete for food, may be displaced by younger, stronger animals, and may suffer from age-related diseases such as arthritis, dental disease, and organ failure. However, older dolphins also possess knowledge and experience that are valuable, and they may maintain social status and influence through their relationships and social skills rather than physical dominance. I navigate using multiple cues. Echolocation provides detailed information about the immediate environment, but for long-distance navigation, I rely on other senses and cognitive maps. I use the sun, detecting the angle and polarization of sunlight, even on overcast days, to determine direction. I may use the Earth's magnetic field, detecting it through magnetite crystals in my tissues, though the mechanisms are not fully understood. I use acoustic landmarks, distinctive sounds such as waves breaking on a reef or the calls of other marine animals, to orient. I remember the locations of resources, such as productive foraging areas, and I return to them repeatedly, demonstrating spatial memory. I follow coastlines, depth contours, and current patterns, integrating multiple sources of information to navigate accurately across hundreds or thousands of kilometers. Some dolphin populations undertake migrations, moving seasonally in response to water temperature, prey availability, or reproductive needs. Coastal populations may shift north in summer and south in winter, tracking preferred temperature ranges. Offshore populations may range widely, following schools of fish or squid that themselves migrate. Other populations are resident, remaining in a relatively small area year-round. These differences reflect the variability of the species and the diverse strategies dolphins employ to exploit their environment. My ecological role is that of a mid to top-level predator. I regulate prey populations, exerting top-down control on fish and squid communities, and I influence the behavior and distribution of prey through predation risk. Prey species may alter their habitat use, timing of activity, or schooling behavior to reduce the risk of encountering dolphins. I also serve as prey for larger predators and as a host for parasites and commensal organisms. My feces and urine contribute nutrients to the water column, supporting primary productivity. When I die, my carcass provides a substantial resource for scavengers, including sharks, crabs, and other marine organisms, and the nutrients released by decomposition support microbial and planktonic communities. This process, known as a whale fall or dolphin fall, is an important, though ephemeral, ecological event. I am a cultural species. Cultural transmission, the passing of information and behaviors from one individual to another through social learning rather than through genes, has been well documented in bottlenose dolphins. Different populations exhibit distinct behavioral traditions, such as sponging, strand feeding, and specific foraging techniques that are maintained over generations and are not explained by genetic or environmental differences alone. These traditions are learned socially, often from mothers, and they shape the behavior and ecology of individuals and populations. Culture influences my diet, my habitat use, my social interactions, and even my communication, with different populations developing different vocal repertoires and dialects. Human beings have interacted with dolphins for thousands of years. Dolphins appear in ancient art, mythology, and literature, often portrayed as helpful, intelligent, and benevolent. In Greek and Roman cultures, dolphins were associated with gods and were considered sacred. Dolphins were said to rescue drowning sailors, guide ships, and befriend humans. Some of these stories may have a basis in real interactions, as dolphins do occasionally approach boats and swimmers, displaying curiosity and playfulness. In other cultures, dolphins were hunted for food, oil, and other products. Drive hunts, in which dolphins are herded into shallow water and killed, have been practiced in Japan, the Faroe Islands, and other regions for centuries. These hunts remain controversial, with concerns about animal welfare, sustainability, and the conservation status of affected populations. In modern times, dolphins have been captured for display in aquariums and marine parks, where they perform tricks, interact with trainers, and serve as subjects for research. Captive dolphins have provided valuable insights into their biology, cognition, and communication, but the ethics of keeping dolphins in captivity is contentious. Critics argue that confinement in tanks, even large ones, cannot replicate the complexity and scale of the natural environment, that social groups in captivity are often artificial and unstable, and that the stress of captivity and performance negatively impacts welfare and health. Proponents argue that captive dolphins serve educational purposes, inspire conservation, and contribute to research that benefits wild populations, and that modern facilities provide high standards of care. Public opinion on this issue is divided and evolving, and some countries and regions have restricted or banned the capture and display of cetaceans. Dolphins are also used in military and research applications. The United States Navy and other militaries have trained dolphins to detect underwater mines, locate lost equipment, and guard installations. Dolphins' echolocation abilities make them highly effective at finding objects on the sea floor, and their trainability and reliability have made them valuable assets. However, the use of dolphins in military contexts raises ethical questions about their welfare, the risks they face, and the appropriateness of using intelligent, sentient animals for such purposes. In the wild, dolphin watching tourism has become a major industry in many coastal regions. Tour operators offer boat trips to observe dolphins in their natural habitat, providing economic benefits to local communities and raising awareness of marine conservation. However, poorly managed tourism can disturb dolphins, disrupt their behavior, cause stress, and increase the risk of boat strikes. Guidelines and regulations have been developed in many regions to minimize impacts, such as maintaining minimum distances, limiting the number of boats, and restricting approach angles and speeds. Compliance varies, and enforcement is challenging. Conservation status varies among bottlenose dolphin populations. Globally, the species is listed as least concern by the International Union for Conservation of Nature, reflecting its wide distribution and relatively large overall population. However, some regional populations are small, isolated, and at risk. Coastal populations that inhabit heavily developed or polluted areas face particular threats, and some have declined significantly. The Barataria Bay stock in Louisiana, United States, was severely affected by the Deepwater Horizon oil spill in 2010, with elevated mortality, reproductive failure, and disease persisting for years afterward. Other populations in the Mediterranean, Black Sea, and certain estuaries and bays are classified as threatened or endangered. Protection measures vary by country and region. In the United States, dolphins are protected under the Marine Mammal Protection Act, which prohibits harassment, capture, and killing, with exceptions for scientific research and incidental take in fisheries, subject to strict regulations. International agreements such as the Agreement on the Conservation of Cetaceans of the Black Sea, Mediterranean Sea, and contiguous Atlantic area aim to coordinate conservation efforts across national boundaries. Marine protected areas, fisheries management, pollution control, and research are all components of dolphin conservation, and ongoing monitoring and adaptive management are necessary to address emerging threats. There are misconceptions about dolphins that persist in popular culture. One common myth is that dolphins are always friendly and safe around humans. While dolphins are generally curious and often approach people, they are wild animals and can be aggressive, particularly males or individuals that feel threatened or cornered. Dolphins have been known to bite, ram, and injure humans, especially in situations where people attempt to touch or interact with them inappropriately. Another misconception is that dolphins are universally altruistic, rescuing drowning swimmers and protecting people from sharks. While there are documented cases of dolphins behaving in ways that appear helpful, there are also cases of dolphins ignoring or even harassing people in distress. Dolphins do not possess human moral reasoning, and their behavior is driven by instinct, curiosity, social dynamics, and individual personality, not by a conscious decision to help or harm. A third misconception is that all dolphins are the same. In reality, there are approximately 40 species of dolphins, ranging in size from the tiny Maui's dolphin, less than 1.5 meters long, to the orca, which can exceed 9 meters. These species differ in appearance, behavior, ecology, and conservation status. Even within a single species, such as the bottlenose dolphin, there is substantial variation among populations, and failing to recognize this diversity can lead to misguided conservation and management decisions. A day in my life begins in the early morning, as the first light filters down through the water. I have been resting near the surface, drifting slowly, one side of my brain in slow wave sleep, while the other monitors my surroundings. As the light increases, I become more alert and both hemispheres of my brain awaken. I hear the clicks and whistles of other dolphins nearby, members of my pod, and I respond with my own signature whistle, announcing my presence. We gather, surfacing and breathing in loose coordination, and we begin to move, traveling along the coast in search of food. The water is calm and visibility is good. I use echolocation, clicking steadily as we swim, scanning the water column and the sea floor below. I detect echoes from fish, scattered and distant, and I adjust my trajectory, homing in on the signals. The others follow, and we form a loose line, spreading out to cover more area. One of the dolphins, an older female with whom I have a strong bond, detects a school of mullet and emits a series of excited whistles. We converge, increasing our speed, and the hunt begins. We work together, coordinating our movements without explicit signals, a result of years of experience and familiarity. We circle the school, herding the fish into a tight ball near the surface. The fish panic, splashing and leaping, and seabirds dive from above, attracted by the commotion. I dart into the school, seizing a fish in my jaws, feeling the slick scales and the frantic wriggling. I swallow it whole, head first, and return for another. The hunt lasts only minutes, and when the school scatters and escapes into deeper water, we regroup, surfacing to breathe. Some of us have caught several fish. Others, less successful, continue searching. We travel on, moving along shore, passing over seagrass beds and rocky reefs. I detect a stingray buried in the sand, its outline faint in the acoustic image, but I ignore it. Rays are difficult and sometimes dangerous to capture with their venomous barbs, and they are not preferred prey. We encounter another pod, a larger group of dolphins moving offshore. There is a moment of tension, an exchange of whistles and posturing, and then the groups merge, milling and socializing. Young dolphins play, chasing and leaping, and adults engage in tactile contact, rubbing and stroking. I recognize several individuals, associates from previous encounters, and I exchange signature whistles with a male I have known for years. The groups separate after a short time, and my pod continues along the coast. We come upon a fishing boat, and some of the dolphins approach, investigating. The fishermen are hauling in a net, and fish are escaping or being discarded. A few dolphins dart in, snatching fish, and the fishermen shout and wave, though without aggression. This is a familiar interaction, tolerated by both sides, though it is not encouraged. I remain at a distance, wary of the boat's noise and movement, though I watch the activity with interest. By midday, we have fed adequately and we slow our pace, drifting and resting. I float near the surface, eyes half closed, one hemisphere asleep. The sun is bright and the water is warm. I hear the distant rumble of boat engines, the calls of seabirds, and the constant background noise of the sea. The crackle of snapping shrimp, the low-frequency pulses of distant ships, the high-frequency clicks of other dolphins far away. Time passes, and I enter a deeper state of rest, though I surface regularly to breathe, my blowhole breaking the surface without conscious thought. In the afternoon, we resume activity. A younger dolphin, a juvenile male, initiates play, tossing a piece of seaweed into the air and catching it. Others join, and the play escalates with chasing, leaping, and mock aggression. I participate briefly, then withdraw, watching. Play is more common among juveniles and young adults, though I enjoy it occasionally. The playfulness subsides and we move into deeper water, traveling farther from shore. As evening approaches, we encounter a large school of fish and another hunt begins. This time the fish are deeper and we dive, descending into the dim water. My echolocation is critical here as light is scarce. I click rapidly, tracking individual fish, and I strike, seizing one and ascending to swallow it at the surface. We dive repeatedly, and the hunt is longer and more exhausting than the morning session. By the time the fish disperse, it is nearly dark, and we are several kilometers from where we started. We travel slowly back toward the coast, vocalizing frequently, maintaining contact in the darkness. The ocean is alive with bioluminescence, plankton glowing as we disturb the water, trailing light with every movement. I hear the calls of other marine animals, the grunts of fish, the whistles of distant dolphins, the low moans of a whale far offshore. We reach a familiar area, a shallow bay where we often rest at night, and we settle, drifting and sleeping, secure in the knowledge that we are in safe water, among companions, in a rhythm as old as my species. Family, for me, is defined primarily by the mother-calf bond, the closest and most enduring relationship in my life. My mother is the center of my world for the first years of my life, providing milk, protection, teaching, and companionship. She is patient and attentive, guiding me to the surface when I am clumsy, nudging me away from danger, and demonstrating how to hunt. I learn by watching her, imitating her movements, her sounds, her choices. She introduces me to other members of the pod, and they become familiar, part of my social network, though none are as important as she is. As I grow older and more independent, the intensity of the bond gradually lessens, though it does not disappear. Even after weaning, I remain in her company for several more years, and I return to her periodically throughout my life, particularly if I am female. If I am male, I eventually disperse, joining groups of other males and forming alliances, and my contact with my mother becomes less frequent, though I may still recognize her if we encounter each other years later. The bonds I form with alliance partners, if I am male, are also familial in nature, though not based on kinship in all cases. These are relationships of mutual support and cooperation, lasting years or decades, and my success in reproduction depends on the strength and reliability of these bonds. My allies and I coordinate our actions, defend each other, and share in the benefits of access to females. Trust and reciprocity are essential, and these relationships are as important to my survival and reproduction as any other aspect of my life. If I am female, my social network is broader and more fluid, but I maintain close relationships with certain individuals, often relatives or long-term associates. These bonds provide support, information, and companionship, and they may extend across generations, with grandmothers, mothers, daughters, and granddaughters associating and cooperating. The social structure of dolphins is complex and dynamic, and family, in the broadest sense, includes not only genetic relatives but also chosen companions and allies, relationships built on familiarity, trust, and mutual benefit. Human impact on my life is pervasive. The ocean I inhabit is crowded with boats, crisscrossed by shipping lanes and filled with noise. The fish I eat are depleted by overfishing, and some are contaminated with pollutants that accumulate in my tissues. The water is warmer than it was decades ago, and the currents and prey distributions are shifting. The coastal areas where I feed and rest are developed, with marinas, docks, and seawalls replacing natural shorelines. I am watched by tourists, studied by scientists, and occasionally captured or killed, intentionally or accidentally. My fate is intertwined with human choices, and the future of my species depends on how humans choose to manage the oceans, regulate fisheries, reduce pollution, mitigate climate change, and balance their needs with the needs of the non-human life with which they share the planet. I do not understand these dynamics in human terms. I do not think about conservation, policy, or ethics. I respond to the immediate conditions of my environment, the availability of food, the presence of companions, the threats I encounter, the opportunities I perceive. I am shaped by millions of years of evolution, by the behaviors and knowledge passed down through my lineage, and by my own experiences and learning. I am a dolphin, living in the moment, navigating a complex and changing world with intelligence, adaptability, and resilience. My story is ongoing, written in the waves, the depths, and the sounds of the sea.